Hey, you 10. How's it going? Hey, look at that. Kate's already here. Nice to see you, Kate. Can I say thank you so much for your email with your homework? I thought that was fabulous. Well done. We're going to be going through it today, so you'll be able to mark it and get your score, which will be awesome. I have just shared with you, guys, a document for you to keep track of all the homework that I'm going to be giving you. I love to see that everyone's already on it. It's amazing. So you'll be able to fill this in with your data every homework. So every lesson, there'll be another homework. I keep them relatively short. And I know that, sometimes there's only a couple of days between them, but it is really worthwhile trying to get these homeworks done before I go through them at the next webinar. I promise you, it will make you better chemists. I swear it will, honestly. I'll do the register, which is awesome. You guys are already on this. This is amazing. I've already got Chinmun. That's amazing. He's in there. I've got Kate. That's amazing. Got Zihan, which is great. Got Natanya. Well done. Got Adri. Amazing. Doing so well. Got Ethan. Doing well. Who else do we have? We've got Mary. Hi, Mary. Yay, we've got Mary. Whoop, whoop. Mary, one of the best things is about YouTube is you'll be able to watch these as many times as you like. Everybody can, of course. You can. I've been finding that my year 10s, year 11s, 12s, and 13s, all of them who I'm giving these webinars to are all watching them over and over again when they're struggling with certain bits. So if anybody wants to rewatch these, of course, on YouTube, it takes about an hour for it to be uploaded. YouTube does it kind of automatically for me. I don't have to worry about it, which is amazing. But it takes about an hour before it appears on my channel, I seem to recall. There's Fatima. Hi, Fatima. Lovely to see you. Amazing. Doing really well. You guys are on this. It took me like 2 or 3 goes before my other 10s and 11s really knew what they were doing with this. So I'm proper chuffed to bits with you guys today. Thanks so much for coming. We're missing Bo Yang, we're missing Ryan, and we're missing Oleg. That's the only people missing now, and then we'll have a full house. Let's see how long it takes for them to appear. There's Oleg. Yo, Oleg. Oleg in the house. Yeah, amazing. Just Ryan and Bo Yang now to go, and then we can crack on, which will be amazing. So today, in our webinar, we're going to be looking at relative atomic mass from the periodic table. It says to calculate relative atomic mass. Now, you actually do have to do that, but that's part of atomic structure. I'd actually need to check the double award to see whether or not you guys actually have to do that. I'll do that right now, actually. iGCSE chemistry specification. It'll be nice to be able to see whether or not that's actually part of them. And if it is, I might do a little bit of, I might, drop back and do a little bit of revision whilst doing this. Today's lesson is going to be really short. This is a really easy lesson, and you guys are going to find this super easy, which is awesome. Relative atomic structure. Yep, there you go. You are required to be able to calculate relative atomic mass of an element from isotopic abundances. So I'll do that as well today. May as well. So Bo Yang is missing, and Ryan are missing. Can anyone do me a favor and send them a message on WhatsApp just to say, are you coming along to this? Just to remind them of where we are. I've no doubt. There's Bo Yang. He's here. He made it. Yo, Bo Yang. Hi. Loving it. I'm here, sir. T4LLV. Oh, is that Ryan? Ryan, is that you? T4LLV. That's really funny. Okay, cool. We've got a full house. It's a winner. Do we have Miss Ryder here this morning? I'd love to know if she is. Let's see if she says anything on the chat. It'd be cool if she did. Otherwise, I will now crack on. I'm Ryan. Love it. She is coming. Love it. Okay, folks. Right, so we will crack on. I will share my screen with you guys. The first thing I'm going to do is I'm going to go through the homework. And then if you want me to set you... Oh, Jess Ryder. Hi. Thank you so much for coming. Oh, you get to see all my lessons on YouTube now. That's embarrassing, isn't it? So I'm going to start off straight away by going through the homework. Yeah, this was the homework that I set you guys. And then I'll drop in, I'll give you some learning objectives, and we can run through what we've done. If anybody would like, just to quickly show you guys, I also created you guys a sheet. It's nice to see that you guys are all up here already, which is amazing. Yeah, so I've created a sheet just for you to track your homeworks. If anybody would like additional questions, I discovered that my year 10s and 11s, 12s and 13s are all suckers for punishment. And I've got students who keep asking me for more example questions just for practice. I think it's lovely. It means that they're enjoying the chemistry, and it makes a real big difference. So if you want me to do more, I can, and I'll then just insert that into the sheet, and I'm happy to review that in all of these webinars. Okay, so let's run through our naming process. So it should have been relatively straightforward. I'm hoping that this has had some value. I know that, you know, I don't know you guys and what you've been done, and I'm kind of going back and starting calculations again. So I hope you found this useful. So this one, of course, is sodium bromide. Tick it if you got it right, folks. Now notice that that metals, it's just nice for me to do a bit of naming and the rules of naming. So in naming chemicals, naming in chemistry, I'll actually put naming chemicals. Yeah, the first thing is that the metal always comes first. Metal is first in the name and in the formulae. I always think that's quite nice to do. Metal is first, and there's an extra distinct point of this, which is the metal is first, and I'm actually going to change my color here, and name never capitalized, look at that, never changes. Yeah, the name never changes. Hence, sodium on the periodic table is the metal, but also sodium bromide. Yeah, the metal hasn't changed. The non-metals, however, yeah, the non-metals come second. Yeah, non-metals come second. Non-metals second in the name and the formula. Yeah, non-metals second, but the name does change. Yeah, non-metals second, name changes, and name changes from, in this case, from bromine, from ene, ... ene, the ending. I'll do that as example underneath as well. Bromine underlined, and it becomes an ide. Yeah, to ... ide. Yeah, so it becomes bromide. Yeah, I'm sure you guys already know this, but it's nice just to do a little bit of recalling of that. Next one becomes a bit more complicated because we've now got a complex ion appearing. This is calcium. Notice the name is the metal is first, and this becomes carbonate. Now this one's slightly more complicated. I'll add this to the rules. The next thing is with non-metals, the first rule is they become an ide. Yeah, so rule 1, change to ide. Let's show you an example of this. So this is Eg, yeah, Ca2C. This would be calcium carbide. There's the ide. It went from carbon to carbide. But now the next rule is if you have two non-metals, now, I'm actually going to say two non-metals. Specifically, though, I'm going to put this in bold brackets, oxygen as well. Yeah. So, for example, yeah. For example, CO3, CaCO3. Yeah. Instead of ide, the oxygen now changes the ide to an 8. Yeah, I was nearly put arrow to 8. So this is, instead of carbide, it becomes carbonate. Yeah, we'll see more of these as we go through. Next one, metal first is zinc. Metal names never change. Yeah, zinc, and then it becomes, if it just been nitrogen, it would become nitride, but oxygen now appears, so it becomes nitrate. Yeah, that's cool to see. Next one, this is titanium. The name never changes. Titanium. And this time we've got sulfur. If it was sulfur on its own, yeah, which would be TiS2, that would be titanium sulfide. But now we have an oxygen, so it becomes sulfate. And yes, by the way, it is spelt with an F, not a PH. They won't actually mind if you spell it with a PH, but it is old. It's actually an ancient English misspelling. Isn't that cool? We just love that bit of history there. Next one, we've got iron. Fe is iron, standing for ferrous, a very old name of iron, one of the originals. And then it would be, if it was F, if it was Fep, that would be iron phosphide. But now it has an oxygen, so iron phosphate. Ticket if you got it right, folks. Next, oh, now look, there's a great one. So I've now got loads of people in the room who'll be able to all chime in. So guys, on the chat, who's going to be the first person to give me the correct name? Oh, I've just made a mistake. Shucks. So easily done. But it's come out in the wash. Right, Ti and Fe. Yeah, well done, Ethan. Well done. So titanium and iron are both transition metals. Let me show you what that means. Yeah, I just made a mistake. There you go, guys. I am not infallible. So we've got titanium and we had iron. Now, because they're in this block here is called the transition metal block. And if they're in there, you've got to include a number. Now, this is very higher level stuff. This now pushes you up to a level 7/8. This is hard, folks. Yeah, now the reason what you've got to do is you've got to dismantle them. This becomes a whole lot more complicated. I'm gonna now do a bit of teaching over here. So to do naming of this, Ti brackets SO42. Right, what I now need to do is I need to disassemble this. Yeah, we know that titanium is a Tm. That means we don't know its charge. Yeah, the charge on it is unknown. What I now need to do is look at what it's joined to. And it's joined to SO42-. This is why, do you remember I said you had to learn your ions, your complex ions? You've got to be able to do these super quick. And there are 2 of them. So I've got SO42-. So the total charge, I'm going to highlight this, the total negative charge is -4. -4 or 4-, they don't care. Yeah, it's 4-. How many titaniums do I have? I have just 1, which means titanium must be in a +4 charge. Now, just to say, by the way, the proper name for charge in chemistry is called oxidation state. That, I know it's just a whole load of waffle. You don't need it for GCSE, but every now and again it does appear on questions. So it's just something to bear in mind. Hi, Dr. Zarkov. I don't know who Dr. Zarkov is, but hi, thanks for coming in. So this one now becomes, now this is where another thing, Roman numerals. So in chemistry, once you've figured out that this must be a +4, yeah, we now need to put that charge into the name using a Roman numeral. And at GCSE, at chemistry, you only need to know up to 7. Here is, oh, I'm going to do that in a pen. Yeah, so there is I is 1, and then II is 2, III is 3. I keep hitting the keyboard on my other computer. Is 3. 4 is IV, that's 4. 5 is V. 6 is VI. And then the last one is VII. Now, students often ask me, why don't I need to know any further? The reason being is you can't get an atom beyond a +7. So that's the largest one you'll ever see. Now, in this case, it's titanium 4. So I've got to be really careful here. I made a mistake. It's just frustrating that. Titanium 4 brackets IV. Yeah, sulfate. Now, what I'm going to do, folks, is because I don't know whether or not you guys have done this before, yeah, and whether or not you did it, what I'm going to do is if you've put just iron sulfate, that's 1 mark, 1 mark, 1 mark. If you've got that full name, it's 1. If you forgot the charge, if you forgot that, give yourself a half. Yeah, give yourself a half mark if you forgot the charge. Because if you've got the sulfate, then you're doing great. The next one, same thing. So Mr. Duncan only got halves, by the way. This one, let's do phosphate. You guys will have had to look this one up, but I did actually do it on your webinar showing that for A level. A phosphate ion is PO4 3-, and there is 1 ion joined to it. So if that's 3-, yeah, if this part is PO43 minus, and I have one of them, yeah, the minus is, it's -3 overall, then this must be bringing +3 to cancel it out. So that is iron 3 phosphate. That's really hard. By the way, that's a level 9 at GCSE. That there is a level 9. Isn't that fascinating? Phosphate, and that is with a pH, amazingly. If you've forgotten your 3, you can have half a mark. Yeah, I think that's totally reasonable, absolutely. And then what will happen is I'll give you another set of these to do for homework, and then you can then give yourself full marks when you've got the numbers in there. This one is not transition metal, so it's nice and easy. This is potassium, the metal never changes. Potassium nitride, and it's an ide, yeah, because nitrogen has no oxygen, so it's not an 8. Potassium nitride. Oh, this one's interesting. This one's gone into covalent. This is, now you guys should have done bonding already. So all the ones so far, all of these, what type of bonding, year 10? Impress me, year 10. What is the bonding in all of these, please? Impress me. First person on the chat. Come on, who's going to come in first? To race to the finish, to race to the finish. Type of bonding in 1 to 6, 1 to 6. Ethan is coming first. Oleg's in the close second. Who's going to come in third? Who's coming third? Coming in third down the race. Well done, by the way, Ethan. I said Ethane, that's amazing. Ethan and Oleg, well done. Natalia's in third. Kate's in fourth. Fatima's in fifth. Adri's in sixth. Amber's in a close seventh. This is well done, guys. Good job. So these are ionic. Yeah. And now we see a rather unusual guy appear, which is, and this guy, I'm actually going to highlight. It won't let me rub it out. It's annoying. There we go. This guy you do need to know. Yeah. This guy is sulfur with an F, sulfur dioxide. Yeah, you have to include the di because it's covalent. Because that's covalent, simple, low boiling point, weak intermolecular forces, wimps between the molecules. Yeah, sulfur dioxide. And here's another cool question for you, please, year 10. Sulfur dioxide is really bad for the environment. What does it cause? Yeah, what environmental problem does it cause? Question mark. Yeah, and I'm going to put the answer there. What does that substance cause there? Do you know that this has had a well, Oleg, Fatima, well done, smashing this today. Well impressed. Great job, guys. It causes acid rain. Superb. Really impressed. You guys are on this. Great chemistry. Well done. Ooh, another nice naming one coming in there. So we've got, this is, oh, it's a transition metal, folks. It's a transition metal. So I've got to now build it. So I'm going to go CuOH. Right, now I've got OH minus. Got to know my complex ions. There is only one of them. So this must be copper +1. There we go. So this is copper 1 hydroxide. Very unusual, by the way. Very rare. I don't think I've ever seen it. Copper 1 hydroxide. If you didn't put the hydroxide, you can have a half, totally fine. Next, there. Oh, by the way, zinc's an oddity of the world. Yeah, zinc is part of the transition metals, but zinc only ever does zinc 2+. Isn't that cool? So that one there is zinc 2 nitrate. You don't, just to let you know, you do not need the 2 because zinc only does 2+, which means technically you can have a full mark if you've just put zinc. If you just put zinc nitrate, you can have that mark, full mark, absolutely. Last one. Oh, another transition metal appearing, vanadium. Right, so vanadium, I've given you a hard worksheet here, folks. I'm very sorry. Vanadium, right, there we go. And it's in a transition metal. So this is vanadium, and we need to build it. Oh, do you know what? I should build it up here. I've got vanadium bound to 2 sulfurs. Yeah, S3. Now, sulfur is S, but where do we find it on the table? It's in the same group as oxygen. This is a -2 or a 2-, whichever one you want to do. So I've got S2-, and how many do I have? I've got 3 of them. So I'm going to multiply this by 3 because of that number. That means I've got a total charge of -6. How many vanadiums do I have? I've got 2 vanadiums, which means the +6 to cancel out the ± needs to be divided by 2. It's +3. That's a level 9 at GCSE, folks. That's a level 9, I kid you not. That is vanadium. Vanadium 3. That there's level 9. This is a love 9. Hardest is, that's an A star year 10. Vanadium 3 sulfide. Can I have a quick, did anybody get it? Oof, impress me year 10. Level 9? That's hard. Right, now the last 10 questions are actually the ones I wanted you to do. Yeah, it's lovely to do some naming, really lovely. Yeah, but this is the bit I actually wanted you to have a go at. Ethan, outstanding, good man. Doing double award and hitting a level 9. Well impressed, well done. Really proud of you, dude. That's great. Right, hydrogen sulfide. Oh, it's ionic, and it's also really easy because I'm going to try and make, can I make my pen less thick? Yes, I can. We've got hydrogen, which we know is always +1. Oh, won't let me do it there. Hydrogen, of course, is always +1, H+. And sulfur is a -2. Let's now build it. So I've got, try and make my pen a bit thinner. I've got H+ and S2-, crossing down, X factor, H2S. Tick it if you've got it, folks. Tick it if you've got it. Nickel 2 sulfide. Sorry, sorry, read it wrong. Nickel 3 sulfide. So this is Ni3+ and S2-, cross and down. So this becomes Ni2S3. I like it. Next. Oh, they've been mean and given you a phosphate. Oh, it's mean. Manganese 2, which is Mn+2. Phosphate, which is PO43-, cross and down. Guys, this is a level 9. Sorry, level 8, actually. It's actually a level 8 because brackets now appear. Mn3 brackets PO4 twice. Now, I'm going to explain that to you guys. I'm going to quickly explain that to you because that's really hard. That's a level 8, that is. So if I just make my pen a bit thicker. So we've just had manganese 2 phosphate. That's what we just had. So what I have now done is I recognize that the manganese is a single ion. Yeah, you could draw it like this. And the phosphate is also a single unit, a single ion like that. Now, what everyone here would agree is that one of the most important things in the whole of chemistry, one of the things that if I teach this to you, it is more important than anything else in the history of my teaching. Yeah, opposite charges, blank. Guys, what do opposite charges do, please? And then the opposite of that is like charges, blank. So what do opposite charges do, please, year 10? It's going to be who's going to be the first person to get the answer. Kate smashes it out the bag. Well done. Kate's in first place. Oh, I've forgotten. Who is T4LLV? I've forgotten. Is it Ryan? Ryan comes in second, then Zihan in third. Oh, no, not times. No. Not times. No. So check that, Zihan. Look at the other two. Yeah. Opposites. Yeah, I'm Ryan. Yeah, lol. Opposites attract each other. Well done, guys. Did you know that that is one of the most important things I can ever teach you in the history of chemistry? And like charges, what do like charges repel for the second one? Superb, Kate, well done. Like charges repel. So what does this mean? This means that if I have something that's positive and something that's negative, they're going to want to come together. Yeah, they're going to attract each other. Yeah, there is an attraction. Yeah. Yeah, and then there you go. There's an attraction. Oh, it's so funny. And then like charges. I'm glad I've lost my mind. This is what lockdown's doing to me. And then like charges, yeah, like charges will repel each other. Yeah, these guys, yeah, boys fight. Yeah, like charges repel each other. Yeah, they'll move away. Yeah, these guys repel. Oh, it's so funny. By the way, I hope there's no I just put it in a setting there. I've got no issues with any attractions between anybody? Yeah, sorry, my bad, moving on. Don't know that, where's that come from? Don't know. Right, so opposite charges attract. So these guys are going to come together. So I hope everyone would agree, social distancing. I know, right? Everyone's become the same charge. It's a nightmare. The question is, are we positive or are we negative? That's the question, Kate. Yeah, I think I think I'm very positive about the social distancing, but I think there's a lot of people who've become negative. Yeah. I'll stop talking. So I hope everyone agrees that if I had an Mn2+, it is going to attract a phosphate 3- ion to it. It's going to go to it and they're going to stick. I'm going to try and do that as best as possible. Oh, that was rubbish. There we go. There's a phosphate. They stick together. Yeah, we think positively. I agree, Ethan. I agree. Now, would everyone now agree? I don't want this thing. Go away. Delete. Actually, there was a reason why I attached that, because they'd made mistakes on their answers. I always love it when they make mistakes. Would everyone agree that if I have a +2 and a -3, I've got an overall charge of still +1? No. Of -1. There's more minuses than pluses. So what is this now going to attract? It's going to attract another manganese. Yeah, that attracts another manganese. So now it's going to become, now it's +2, and then -3, and then +2 again. Total now is +1 overall. It's going to attract another negative. It's going to attract another phosphate. And that means I'm going to add now another -3, which brings me now back to -2. And then I'm going to attract another manganese, and it stops. Yay, there's the reason. So it's just nice, but would you agree? I have 2 distinct units of PO4. So what that means is in this, I need the bracket to show that I've got 2 of everything. That's the key thing here. Yeah, and that is a level 8, hard that. Next, silver nitrate. This one's easy. You've got to remember silver, of course. So we've got Ag +1, just have to know her. Yeah, and then NO3 1-. These attract and cancel 1 to 1. Final answer, AgNO3. Next, lead 2 oxide. Pb is a +2. Oxygen is always 2-, except in peroxide, except in hydrogen peroxide. Crossover. This now, lots of people may have put Pb2O2. These numbers now cancel. Yeah, they cancel out. So that just becomes PbO is the correct answer. Right, next one. Copper 2 sulfate pentahydrate. Now, there's a reason why I like to include this one, folks, because you have to know this guy. Yeah, this one's important because it's blue. Yeah, so this is Cu2+, SO4 2-. Oh, charges cancel out. So just CuSO4. And now the pentahydrate tells you that there's 5 waters bound to it. Yeah, if you ever have a hydrate, it means you have a dot. 5 is penta. Pent means 5. Pentagon, H2O. There you go. There's that one. And you have to know this one for GCSE, folks. Yeah, it's blue. It's also the test for water because anhydrous is white. I'll do that another time. That's in chemical tests. You should recognize that. Potassium carbonate. K+ from the periodic table. Carbonate from my memory. Crossing down. So I need K2 and 1 CO3. Winner. Ammonium oxide, you've got to know your ammonium ion, NH4+, O2-, crossing down. I need 2 ammoniums. Oh, level 8, folks. Love 8. Yeah, NH4, but it's in a bracket because I need 2 of them. Yeah, and then O. There we go. Next, tin 4, SN+4, selenide. Ugh. Where's selenium? In the same group as oxygen, 2-. That's cool, like that. O2-, crossing down, but they're going to simplify, folks. Lots of people might have done this, but the 2 numbers simplify down to SNO2. Last one for the homework, sodium oxide, Na+, O2-, cross and down, Na2O. There you go, folks. It is out of 20. You can see the level 9s and the level 8s there, folks. Yeah, really cool, that. So you can total yourself up out of 10. Yeah, total yourself up out of 10. Out of 20, and then you can add it to this sheet, which would be amazing. I'd love that. Amazing. Right, and now today's lesson. I've got 25 minutes to teach you my title. Calculating relative atomic mass, relative molecular mass, and relative formula mass. Okay. By the way, don't worry about adding those up now and adding them to the sheet. You can do that later if you want. I just wanted to show you something. Yeah, these are all the answers, but there was a mistake. I always love it when I see people who make mistakes. Notice that the zinc didn't need the Roman numeral. Yeah, there's the others though. But that one shouldn't be 7. If it was 7, just to let you know, that there is copper 2 with an F, copper 2 sulfate heptahydrate. Isn't that cool? That there is beyond, that's now first year A level. Where do we find the sheet? I shared it with you, Kate. I put it onto the classroom, I believe. I went to the classroom and I posted it on the classroom. It's there. There it is. Posted it on our Google Hangout chat. Sorry. It's not on the classroom. It's on the Google Hangout chat. Oh, I'm sorry. Right, let's go back to this. Right. Okay. So, title for today's lesson. Title for today's lesson is calculating. Oh, I'm going to need to make my pen much fatter than that. Calculating RAM. Now that's old. The new way is A subscript R, and it stands for relative atomic mass. Atomic mass. Hence RAM. Yeah, RAM. And then relative molecular mass, RMM. New way is MR. And then I've also mentioned RFM. Now, I want to make you feel all better. Oh, OH. Yeah, they have to be capitals, Kate. Yeah, because they're symbols from the periodic table, they must be capitals for the hydroxides. I don't know where you're getting that from. RFM, that has no other symbol. It's the same. Now these two are essentially the same. Just to explain what the difference is, this one here is for covalent, yeah, and this one here is for ionic. Now people often say, "What do I do?" You don't do anything. I just need to make sure that you recognize it. Oh my God, I've just suddenly realized what you're doing, Kate. And then you wrote it in capitals. I'm such a doofus. I'm an idiot. Now, guys, this lesson is super easy because I'm going to teach you this in exam-style questions. So, question number 1, I'm going to give you H2O and say, what is the RMM, H2O, what is the RMM of water? So they're saying relative molecular mass in the question. Now, what you're doing is you need to understand that all atoms have a mass. We all know this, yeah? If we go to hydrogen on the periodic table, hydrogen has a mass of 1. Yeah, there's its mass number. So hydrogen has a mass of 1. There it is. Now that hydrogen is bound to oxygen. Now oxygen has actually got 2 H's bound to it. So they're joined by sticks. I'm just going to move them closer, make them a bit more even. There you go. And each hydrogen has a mass of 1. Yeah. Oxygen on the periodic table, oxygen has a mass of 16. The top number is the mass number. So I've now got an atom weighing 16 joined to 2 atoms each weighing 1. So the relative molecular mass, why molecular? Because this is a molecule, because it's covalent. Yeah, molecule. And so all we do is 16 plus, I'm going to go oxygen 16 plus hydrogen 1 times 2, and I get an MR of 18. Dead easy. Mr. Duncan, is there LOs for today? Can I have them? LOs. Number 1, no I'm going to put no periodic table. Periodic table. Brackets, top mass number. Mass number. E.g. oxygen being 16. Always useful. The most useful one, do you know what the most useful one is, folks? Carbon. Comes up so often, it's 12. Yeah, mass number. Next one, understand RMM and RFM are same, but bonding different. Yeah, U is understand. And the last one is be able to calculate RFM and RMM. There's my learning objectives for today, folks. So we're already making grounds on this one. We've already started to realize that we can pick up the mass numbers, and it's the big top number that's going to be helpful in this case. Yeah? That mass number is the total number of protons and neutrons. I don't want to take that away too quick, folks. You can always pause the video if you want to. More than welcome to. Okay, so we've just worked out the weight of water. Can I now say, by the way, it's worthwhile learning that. It's worthwhile learning. Knowing that water weighs 18, it comes up so often at GCSE and A-level that it's just one of those numbers you get used to. Right, guys, now that you've seen me do that one, I'm going to give you another one. And this one, I want you, please, question number 2, sodium chloride. RFM, relative formula mass. Let's see who's first on the chat to give me the correct number. I've suddenly realized you're going to need a periodic table. There we go. I'll give you a helping hand if you like. There we go. And I'll do sodium chloride. What is its RFM? Notice that I've said RFM because it's ionic, but it's the same thing. The process is the same. Who's going to be the first person on the chat to give it to me? Who's going to tick my learning objective off first? I know that people will have paused based on the learning objectives. They're going to be trying to write them down. I'm totally aware of that. Ethan, smashed it. Dead easy. He's on it. Who's going to be next, Ethan? Amber, well done. Zihan, well done. You guys are great. Adri, outstanding. Kate, Natanya, well done. Great job. You guys are all over this. Bo Yang, where are you? Fatima, well done. Good job. Mary, how did you get on? Did you manage it, Mary? It'd be nice to see if I can get Mary to post her number. Is Mary still there? I know that she's probably pausing the video, so I'll move on. So, okay. So sodium is element number 11 and 23. Top number is the one I now need. Chlorine, element number 17 and 35.5. Top number is the one I need. And I now get 23 plus 35.5 gives me 58.5. Great job, Bo Yang. Well done. 58.5. That's it. We're done. 58.5. Right, guys, I'm now going to make them steadily harder. Are you ready? I'm going to make them get harder and harder as we go through. Can I just point out, by the way, there's my second learning objective. Tick. And my third. Yeah, we're busy. So this is RFM. So then we go question number 3. Right. Here, do you know what? I'm very impressed. Let's make this a lot harder. C6H12O6 RMM? Question mark. Off you go, folks. First person on the chat. Come on, folks. Come on. First person on the chat. Who's going to get there? Come on. Who's going to get there? Boop, 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 doo. Come on. Come on. Zihan's gone completely mad. Completely mad. Absolutely off the... Well done, Ethan. Zihan, look at your number. 1,224. That's enormous. Well done, Ethan. Well done, Amber. Well done, Natanya. Great job. Let's look at how they did it. So I have got carbon, which is 12, but there are 6 of them. Times that by 6. I'm going to add that to hydrogen, which weighs 1, times by 12. I'm going to add that to oxygen, which weighs 16, times by 6. I'm going to add all these together, and I get 180. There you go. I know, absolutely, Zian. I totally knew there was a calculation error. You'd forgotten a bracket, which meant you probably multiplied up 2 things simultaneously. It's very common. By the way, that's glucose. Whenever I watch darts, yeah, and I see them throwing the darts and they get that triple 20 3 times, I go, glucose! That's and then everyone shouts at me. I don't know why they get so annoyed at me, especially the dart games. Right, guys. Oh, check you guys going, oh, this is easy. Yeah, let's make it harder, folks. I've got skills. Let's make it harder. Are you ready? Let's go for, all right, let's go for this guy. Impress me, folks. Impress me. Go. That's now hard calcium phosphate. You have to find phosphorus on the periodic table. I'll give you the periodic table. I'm having to build the formula in my head, by the way, just so you know. I'm actually doing it as well. It's big. It's really big. No, it's bigger than that, folks. It's bigger. 246. I got a much bigger number. Try again. Nobody's got it yet. It's the oxygen, guys, that's ruining you. Still incorrect. Still no one with the right answer. I've just run it again. Still no one with the right... Oh, no. Oh, I've made a mistake. No, I got it wrong. No. Oh, I can't believe I just did that. Oh, that's so upsetting. Oh, no. I made a mistake. Well done, folks. It is 310. Let's run it. So I've got calcium at 40 times by 3. I now have phosphorus plus brackets phosphorus, which is 31 times by 2 because of the number outside the bracket. And then I then have oxygen at 16. But there's 4 and a 2. So that's now times 8. And I get a total of 310. Winner! Well done, guys. Good job. I actually made a mistake on that. I did a 3 there. Oops. But well done. That's superb. By the way, do you see how these are going up in difficulty? That now is a level 8. I kid you not. Guys, you are doing so well. I'm really, really pleased. Keep it up. Are you ready for a harder one? It doesn't end there. Question number 5. Let's go for this guy. This is, I'm going to wonder if anyone can actually name this. I'm trying really hard to, let's go for that one. So I'm going to ask, this now, by the way, is a level 8 as well. This is a level 8 as well. Level 8, 9, actually. Can somebody on the chat name it for me? Somebody name that for me. Impress me. And then, and obviously then I've got to work out the MR. I've got to do it myself. Oh, no. Done. Oh, surprisingly small. Wowza. Isn't that interesting? Ammonium Fatima, outstanding. Well done. Natanya, Ethan, superb. 96 is correct. Oh, no, Fatima, you're wrong. It's ammonium. Really close. That there is ammonium. I'm underlining the ium. Yeah, just to make that really clear, that's I-U-M. Yeah. Ammonium carbonate. Now, this is a really unusual one. Yeah, ammonium carbonate. The reason being is NH3 is ammonia. Well done for knowing that. Yeah, and then when it becomes NH4 plus, it's the only positive ion that changes the name. Ammonium ion. So that becomes ammonium carbonate. And the answer is 96. Outstanding. Great job. Yeah, I'm just going to erase that, although I probably shouldn't. So we've got nitrogen at 14 times by 2. It's going to give me 28. Plus, hydrogen's the tricky one. It's the one that everyone makes the mistake with. Hydrogen 1, oopsie. Hydrogen 1 times by 8. Yeah, and then plus carbon, which is 12, and oxygen at 16 times 3, and I get a total of 96. Great job, guys. Wow, you guys are finding this way too easy. You ready for the next one? Let's go for the next one. Smashing this now, guys. Let's go for question number 6. CuSO4.5H2O. This is copper sulfate pentahydrate, and it is a blue crystal. Yeah, it's a blue solid. Blue solid. They're rather pretty too. You all will have seen them. Really, really pretty. So what's it? This is ionic. So this is relative formula mass, please. Annoyingly, I actually know this one off the top of my head because it comes up so often. I'll put it on the periodic table in case you guys don't have it. Yeah. So CuSO4.5H2Os. Yeah. So copper, sulfur, oxygen, hydrogen. Yeah, all in there. Where you guys are good. Mary, so close. You're not quite right. Check your numbers. Kate's got it wrong. Ethan has it correct. Well done, Ethan. Well done, Mary. Great effort. You're getting better. This is one of the hardest ones that I've done so far. Yeah. Look at all the different answers. Oh, Mary, well done. You star. Good effort. Well done. That's amazing. Let's go through it. So I have copper here at 63.5 times by 1. I have sulfur at 32 times by 1. I then have oxygen is 16 times by 4. Yeah. And then I have water, but I have 5 of them. So the hydrogens, H1, I actually have 10 times by 10 plus oxygens times by 5. That's hard. Oh, run it through my calculator. 63.5 plus 32 plus bracket 16 times 4 plus 10 plus brackets 16 times 5, and I get 249.5. Winner! Well done, guys. It's hard, right? Are you ready for your next? You guys are like, oh, this is hardcore chemistry. This is amazing. We're doing brilliantly. Yeah. 7. Question number 7. Let's go for, going to give you something really cool. K2Cr2O7. This is called potassium. This is needed for year 11 chemistry, by the way. Potassium dichromate is what that's called. So give me its, by the way, and this is ionic, relative formula mass. I've suddenly realized I haven't given you many covalents. I'm going to give you a covalent. I'm going to give you a really cool one. We did do one. We did glucose. That one's a nice one. Like it. 294. Oh, is that correct? Let's run it. You guys are like, this is easy now. I love that. That's great. 39 plus chromium. Oh, times by 2. Ooh, so close, Mr. Duncan. Come on, better than that. Plus brackets chromium. I have no idea. 52. 52 times by 2 plus oxygen 16 times 7. Haven't got a clue what that is. 39 plus 39 plus 52 plus 52 plus bracket 16 times 7. Not typing over. 294. You guys are on this. Did you guys just go, now it's so nice to go to those really tough ones. And then when you get one like that, it's like, This is easy. That's the way chemistry should be. Oh, how crazy am I going to go? All right, guys, I'll let you pick. Do you want hard, really hard, or super, super, super hard? You may choose. I'm just tempted. Do you want me to give? I can give you an A-level one if you like. Can be done. Super, super, super hard. I like it. Good job. Okay, fine. So let's go for I'm having to build it in my head, by the way, guys. That there is from A-level. Yep, I know. How mad's that? Isn't that crazy? You realize, guys, when you go from GCSE to A-level, they just add in the extra level of difficulty. That's all they're doing. They're just going, all right, if you can do these easy ones, well, can you do the really hard ones? They're just adding this extra level, adding more brackets. It means there's more chance of an error. It's not complicated. It's just an extra evolution. This is, just to let you know, this is hydrated potassium ammonium sulfate. If anybody's curious on the name, this is hydrated potassium ammonium, didn't need the capital there, ammonium sulfate. How amazing is that? Naming it A-level, gotta love it. Right, I've got two numbers. Let's see. Right, potassium, K, 39 times 2, plus nitrogen, brackets, nitrogen is 14 times by 2. Next one, hydrogens. Oh, tricky one, most common mistake. 1 times 8, because the 2, we've got 4 inside it and then 2 outside, so it's going to be an 8. Yeah. And then we then add it to, 2 sulfurs. Sulfur is 32 times by 2, brackets, plus oxygens, next point of error for students at A-level, brackets, oxygen is 16 times by 8. And then they're going to go plus, brackets, how many hydrogens? Oh, there are 2 in each water, but 12 times by 20. So that's hydrogen 1 times by 24, close brackets, and then 12, and then oxygen 16 times by 12. Oh, I'm going to have to type that all into my calculator. 13, so open brackets, 39 times by 2, plus brackets, 14 times by 2, plus brackets, 8, bracket, plus bracket, 32 times 2, close bracket, plus bracket, 16 times 8, close bracket, plus bracket, 1 times 24, close brackets, plus 16, oh, need a bracket, 16 times 12. And that's what they do at A-level. 522. Who got it? Nailed it, folks. Ah, year 10. I am so... Year 10. We're done. I will, on the classroom, I will post your homework, which is just a whole load of working out the relative formula masses, the molecular masses, the compounds. Year 10, can I just say how proud I am of you guys? That was amazing to see. Like, I'm completely blown away. That was brilliant. I just gave you one of the hardest A-level relative formula masses that I have ever seen in 15 years of teaching, and you smashed it. I'm so, so impressed. And Miss Allday will be super proud of you. That was amazing. Guys, it is the end of the lesson. Go and have a lovely rest of your day, and I will see you guys. I'll see you guys next lesson. See you soon, everybody. Ciao. Bye.